Okay, so today we're going to talk about linear inequalities. Let's first kind of review regular inequalities. When we would have, let's say, oh gosh, I'm going to make a bad inequality here. Hopefully it'll work. 2x plus 4 is greater than 9. Okay, and we would subtract 4 from both sides. That would leave us 2x is greater than 5. Yeah, of course, I have to make it so that it doesn't work, perfectly, but that's okay. We know that here we've got x is greater than 2.5, okay, and then we would graph it. We would take our number line, and this is just if you're not remembering this, this is something that excuse me, you can get on to Khan Academy and remind yourself. So we've got 0 here, don't forget our negative side here, positive side here, 2, 3, negative 2, negative 3. And because it's greater than 2.5, we know that here is our 2.5. We know that it starts here but does not include that. And we have our variable on the left, so we know that our arrow is going to go in this direction because we are going greater than 2.5. If, as a reminder, when we had an answer, when we graphed something that was, let's say, x is less than or equal to 4. Here, let's just do 0 here, and 1, 2, 3, 4. When it is inclusive of that, we know that we are putting a solid circle, and then our arrow going in this direction. Okay, so that's just a quick reminder of our inequalities with one variable. Today we're going to be talking about linear inequalities. So once again, we are going to our two variables, and but we're going to use the same kind of principle, because when we are graphing these linear inequalities, and let me just go ahead and throw a coordinate plane on here, and let's say we've got, let's say just something very simple. Let's do y is less than 2x plus 3. We're going to go ahead and plot these points first. 3 and positive 2 on our slope. 2, 1. Now, y is less than this, okay? So what we have to understand is that whatever points are along this line, because there's no equal to part of this, our line is going to be dashed. It's kind of like leaving that open circle, okay? So less than or greater than, we are going to make this line just dashed. This says, here is my line, but please note that the points along this line are not included in my solution. Now, when I graph this inequality, what I'm looking for is all of the points that satisfy that equation or that inequality, and I have to shade those points that are included in the solution set. Now, the best way to do that, especially when you're starting out, is to test a point. Now, I don't know about you, but for me, the easiest point to test is good old origin 0, 0. So I'm going to go ahead and put that point into this inequality, and what I get is 0 is less than Now 2 times 0 is 0, and so I get 0 is less than 3. Well, is 0 less than 3? In my book, it is. Okay, so I now introduce the colored pencil. I'm going to be using green and red. Yes, it's the season of Christmas, and so I'm going to use Christmas colors. Okay, so anyway, 0 is indeed less than 3. And 0, 0 is down here, which is underneath, and so I am now going to shade that portion of the line of the coordinate plane that is under. So now I have identified the fact that here is my starting point, and all of the points that are under here will be solutions to my inequality. So so that's kind of what we're working with here. Now, sometimes you have to do a little work to get to this. So let's go ahead and graph another one, and let's say we've got 6x. You really can't see a darn thing there. 6x plus 8y equal is greater than or equal to 12. I'm so used to doing the equalities that sometimes my writing of the inequality is wrong. Okay, so anyway, I am going to go ahead, build my coordinate plane. I know that because I am working with greater than or equal to, my line can be solid. It's going to be a solid line. So I don't have to worry about dashing my line. There's a couple of things that, you know, when I'm doing this, I just kind of think about it first because makes it a lot easier. So I'm going to go ahead, because I'm in standard form, I'm going to go ahead and do this, well, I don't know. Do I want to do it that way? No, I'm going to go ahead and I'm going to rewrite it in slope-intercept form. It's just easier when we're talking about our lines greater than or equal to, no, let's go ahead and do standard form. So 6x greater than or equal to 12, and so x is greater than or equal to 2. So x, I'm at 2. Yeah, see, that's where it just doesn't work out that well. Let's see. Yep, no, it's good. So there's that. And y, I guess I'll go over here. 8y greater than or equal to 12 over 8. Yeah, this is where it gets just a little bit. 12 over 8, 6 over 4, 3 over 2, or 1.5. So I'm a little bit inexact here, but that's really pretty good. So if you wanted it to be more exact, you would have to convert the line. Anyway, so here is my line. Remember, I know that it can be a solid line. Okay, now once again, I am going to put 0, 0 in as my point. And so putting 0, 0 into this equation, that makes this 0 and this 0, and so this would come out to 0 is greater than or equal to 12. And I think that we all know that this is like, no, that's not right. So I cannot shade under there. So now I'm looking at shading up here. And there's the red. Merry Christmas. Oh yeah. And look how lovely I'm shading. Okay. You can actually just use your pencil. I just like color. Okay. So that is the solution for that. As we're doing more of these, we'll have some that are real world problems. So let's go ahead and look at one of those. And we've got a problem where we plan to spend no more than $24 on meat for a cookout. So our meat has to be less than or equal to 24. Okay, and at the and that's all of the meat has to be less than or equal to 24. So our hamburger costs $3 per pound, and chicken wings, we'll just say chicken, costs $2.40 per pound. Okay, and we want to find the possible combinations of how we can do that. So the easiest way to find combinations is to go ahead and graph it. So let's say that we have got our coordinate plane, and we know that our equation here is 3h plus 2.4c has to be less than or equal to 24. Now, I understand that what I have just done is not a proper standard form, but sometimes you just have to kind of let that go a little bit, okay? So, and I don't know why I did all of these quadrants, because none of these make any sense. It's only the one quadrant. And so I'm going to go ahead and I'm going to put my hamburger down here and my chicken over here. And I am going to say if I set each of these to 0, so let's say for my hamburger, 3h less than or equal to 24, so h less than or equal to 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, here is where I'm buying just hamburger, no chicken. And if I do the chicken, 2.4 c less than or equal to 24, and then dividing by 2.4, hopefully we can see that we've got 10 c is less than or equal to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're way up here, which is completely off my graph because I wasn't really thinking properly. Okay, so this is if I just buy all chicken and no hamburger, and all of my solutions are going to be between these 2 points. Okay, and we know that it has to be below because I can't spend more than $24. I can't go up here, so everything has to be in this area here. I'm going to just shade all of this. So anything on that line or in here is going to satisfy my my problem here. So let's say I pick this point right here. So this is 2 pounds of hamburger and 1, 2, 3, 4, 5, 6, 7, and 7 pounds of chicken. So 2 pounds of hamburger is $6 plus 7 pounds of chicken. And here, let me do my calculations down here. So 2.4 times 7, 14, 16, 0.8. 6 plus 16.8. Hopefully this is less than or equal to 24. And 16 plus the 6 is 22.8 is less than or equal to 24. And so that does check. So you can either find a point that appears to be on an intersection point, or any point that's in here will work because you have satisfied all of your parameters. Gosh, I hope that works out okay for you. and I hope you understand what I just did. And sorry that sometimes we've got to be a little flexible with our standard form. Okay? So that's it on that. I hope that it was all good. Okay? And I hope you enjoyed my coloring.